All right, so let's have a look at number 7 here. Okay, we did number 6 yesterday. All right, so let's have a look at number 7. Remember, when you run into a heating curve question, the first thing you want to do is draw a rough diagram of the heating curve and mark on it your starting point and ending point. So it says here we want to calculate the total heat required to melt 0.1 kilograms of ice. That's 100 grams. Okay, initially at minus 20. So that means we're starting down here, and it says the final temperature will be 0 degrees Celsius. How many steps is that going to be? 2. I have to heat the ice to melting, and then I have to melt the ice. All right. What we have to remember now is anywhere where the line is going up, I use E equals MC delta T. Anywhere where the line is flat, okay, I'm using one of my E equals ML formulas. Okay. In this case, I'll be using the latent heat of fusion because I'm melting the ice. All right, latent heat of vaporization is for up here. Right, this section of the graph is E equals MC delta T, as is this section. All right, so this one has only got these 2 steps. All right, so what I do then is just write down step 1, stepped 1. That's weird. Step 1, okay, and that's going to be E equals MC delta T. We said the mass was 100 grams. We're melting we're heating ice, so I have to use the specific heat capacity of ice, 2.116 joules per gram degree Celsius, and I'm heating it from minus 20 to 0. So what's my temperature change? 20. All right, so 100 times 2.116 times 20. All right, gives us 4,232 joules. Okay, and then step 2, I need to melt the ice. E equals MLF. All right, which simply means plug in our numbers. 100 grams times the latent heat of fusion for water, which we learned yesterday is 333 joules per gram. All right, so we're looking at 33,000 joules. All right. Everybody with me there? All right, what do I do with those 2 numbers now? Add them together. Okay, when I add them together, I should get 37,532 joules. All right. Ringing a bell? Okay, what I want you guys to do, okay, is try number let's do number 8. Have you guys try number 8 here. Okay? I'll give you a couple minutes to work on number 8. We'll go through it together, and we'll move on to biomes. All right, let's have a look at number 8 here. So we draw our heating curve. All right, we want to convert 0.05 kilograms, that's 50 grams, of ice initially at minus 10, so down here, into water at 80. That's up there. All right, how many steps? 3. I need to heat the ice to melting, melt the ice, heat the water. All right, so that's 3 steps. All right, in this step here, since temperature is changing, I use E equals MC delta T. Okay, here where I'm changing the state and the temperature is not changing, I use E equals MLF. And here, where I'm heating up the water and temperature is again changing, E equals MC delta T. Okay. All right, so for step 1, all right, I'm heating from minus 10. Okay, so my E equals MC delta T is going to be 50 grams times the specific heat capacity of ice, 2.116, times 10 degrees Celsius. All right, so we're looking at 1,058 joules. All right, so that's, now I've got ice at 0 degrees Celsius. Now that if I keep heating up ice at 0, it's going to melt. Step 2, okay, E equals MLF. So 50 grams times the latent heat of fusion, 333. And it gives us 16,650 joules. All right, and then after that step, I have liquid water at 0 degrees Celsius. If I heat it up, its temperature will change, so that's E equals mc delta T. So that's going to be 50 times now the specific heat capacity of water. Okay, so now it's 4.2. Okay, times, I'm heating it up to 80, so the temperature changes 80 degrees. Okay, so we'll have 50 times 4.2 times 80. All right, and that gives us 16,800 joules. All right, so my total energy required, okay, is add all those together, and I get 34,508 joules, which I believe is also what happens to be on there. All right, is that making sense? Okay, expect probably about a 3-step latent heat question on your unit exam, possibly again on your final exam. All right, again, they're not hard. You don't have to manipulate anything. You just need to plug numbers in. Okay, questions on that? All right, take out your notes package. Lesson 7 in this unit is biomes. It's a rather long section of the notes package because there's a lot of information in there, and you're going to want to highlight or underline some of it. All right. All right, so we got biomes of the world here. So basically, guys, what a biome is a biome is a geographical region on Earth that has definitive characteristics. All right, that means it's an area on Earth that is different from other areas on Earth based on a few things: climate, soil, animals and plants. Okay, and then maybe nutrient cycling might be the last one. But generally, we look at biomes based on their climate, and the climate determines what plants and animals can live there, and that is, in the end, what makes one biome different from another. All right, so what we're going to look at basically here, guys, is just the different biomes. What are you going to be expected to do with that? This. On a multiple choice question, I show you a picture of a biome and give you a description, and you correctly identify it in a multiple choice item. Pretty easy, especially with a picture. Really, it's hard to miss. Okay, the second thing, I show you a climatogram, and you tell me which biome you think it is from, and explain or justify your choice. Those are the two things you are going to have to do with the information from this lesson. So I'm integrating what's in here with your ability to read a climatogram. All right, everyone follow? I'm going to go over. I'm going to show you climatograms from each of these so you kind of get the idea. Okay, here's where all of the major biomes are located on Earth. Okay, the ones we're going to go over. First one, tropical rainforest. And you can see here, it's this kind of light green color. Right? We see a lot of it here in South America. So this is like, you know, Brazil and Colombia and Ecuador and places like that. Okay, there's a fairly major swath of it missing here. That might be expanded now due to all the deforestation and slash and burn agriculture that goes on down there. All right, there's some tropical rainforest in the Horn of Africa, the southern end of Africa over here, a little bit of Madagascar, and almost all of Southeast Asia. That would be Vietnam, Laos, southern China, Papua New Guinea, and all of those kind of places, Malaysia, all right, those kind of places there. And that's pretty much it. Where do you notice all of the tropical rainforest? There's some here also in the Caribbean. Okay, where does it all occur? Close to the equator. Okay, tropical rainforests can only exist near the equator because they require certain climatic conditions. Heat being one of them, heavy rain being another. All right, so when we're looking at a climatogram of a tropical rainforest, we are probably going to see high bars most of the way across for precipitation, and we're going to see a high line as well. Now, is that line going to have a bell-shaped curve, or is it going to be flat? Flat. Okay, The closer you get to the equator, the flatter the temperature line gets because you don't experience seasons as much at the equator because you receive the same amount of sunlight all the time. The tilt of the Earth's axis doesn't really affect you when you're near the center, right? It affects us because we're a long ways away, and it really increases and decreases the intensity of the sunlight we receive. All right? It also really influences the length of our day, whereas at the equator, you don't really notice the change from winter to summer. Okay, the difference if you live, let's say, in like Hawaii or something like that. I remember actually when I was in Hawaii the last time, this lady was complaining about how short the days were getting. I'm like, really? How short are the days? She's like, well, they're only 11. The daylight is only 11 hours and 15 minutes now. It's about as short as they get because it was around Christmas time. And I'm like, you don't know the half of it. Okay, you come back with me and I'll show you short days. All right, you know, the sun comes up at 10 o'clock in the morning and it's gone before 4. Okay, yeah, those are short days. People just don't have a clue sometimes. All right, so obviously as you're close to the equator, your amount of sunlight doesn't change, so your temperature doesn't really fluctuate either. All right, the next one we're going to go over will be the savanna. Okay, the savanna you can see is mostly in Africa. All right, so this is kind of, you know, the safari area where you got you know, lions and tigers, but not bears. Okay, but you got like hyenas and buzzards and giraffes and wildebeests and all of that kind of stuff. All the stuff you would see out in Africa there. Okay. You see a little bit of it in South America as well. Again, some of that is artificially created by deforestation of the rainforest. Okay, but again, savanna is very much an equatorial climate. You simply don't see it outside of about 30 degrees of the equator. All right. Desert. There's different kinds of desert. All right. There's hot deserts and cooler deserts. All right, and then there's obviously like Arctic frozen deserts as well, but those are different. All right, deserts typically don't have to be hot; they just have to be dry. They're dry is the big thing. All right, because if we look in here, sure, we got the Sahara. Okay, the Sahara is bad. It's a desert. It's very dry. It's also very hot. Okay, but there's deserts in North America as well. Okay, and those are cooler. Okay, those deserts sometimes even have snow in the wintertime. But the key thing they all have in common is they're very, very dry. Okay, so heat-wise could be different, but always very low on the bars. Okay, on the climatogram. Okay, is going to indicate desert. All right, extreme deserts. Extreme desert is like rock and ice. If you go up onto the Columbia ice fields, you're in extreme desert. All right, there is nothing there alive. All right, there is just rock and ice. All of Antarctica, if it was on this map, which it is not, okay, would be that color. It's nothing but glaciers and mountains and nothing else. All right, everyone follow me there? If you're looking at the climatogram for the extreme desert, you're not just going to see, okay, very, very low bars all the way across. You're going to see a temperature line. If this is 0, okay, you're going to see a temperature bell curve that looks like this. Right? It's going to stay below 0. Maybe even significantly below 0. All right? It's going to be a curve, and it's going to be very dry. And the curve is going to be very, very low. Everyone follow? Yes? Okay. Chaparral, okay, often has a lot of different names. It's usually referred to as the Mediterranean climate or sclerophyllous forest biome. Okay, the reason we typically call it Mediterranean, it's about the only place on Earth you find it. All right, so Italy, Greece, okay, all those kind of Mediterranean areas are very much similar in climate. It's drier, it's very hot in the summer, cooler winters, okay, but you know, different types of plants and animals live there, like, you know, olive trees and things like that. Not kind of typical of anywhere else. You do see a little bit of chaparral kind of in Southern California, a little bit, it's more closer to desert there, okay, but those are about the only places, maybe a tiny bit on the tip of Australia. All right. Temperate grassland. Temperate grassland is big. Right? Temperate grassland is basically all of this area here. Okay? And much of Asia. We sometimes call it the grain belt because it's where we produce the majority of our agriculturally produced food. Okay, this is where there's lots of soil that is rich in nutrients. Okay, growing seasons are favorable. Okay, grazing animals can be supported, things like that. Okay, so typically you see it there. All right, and you can notice that the desert kind of stuff is often right beside it. And in fact, if we look closely here, maybe if I get Julianne to turn off the lights there, you can see the colors a little bit better. Just the front's fine, yeah. Okay, you can see that there's this finger of desert right in here. Okay, you can actually see the outline of the desert right here, right? That's the Gobi Desert. It's the rain shadow desert created by the Himalayas. All right, because right in there, okay, these are the Himalayas right here. All right, remember I was talking about the rain shadow when we first talked about climate? Okay, this is the rain shadow of the Himalayan mountains. Stuff just comes in, and you can see that the majority of the precipitation falls here on the windward side of the mountains. Okay, you got tropical rainforest on that side, and most of that precipitation is gone by the time those clouds are forced up and over the mountains, that there's nothing left on the other side. Same thing happens over here. Okay, you can see that it's not desert, but it's grassland, and that's the rain shadow of the Rocky Mountains. Okay, so that's that rain shadow effect that we were talking about in the first unit. So you often see deserts and grasslands in the rain shadow of mountains. After that, we got the temperate deciduous forest. What do deciduous trees do every year? Change, right? They lose their leaves, right? They change to orange and drop their leaves every year. All deciduous plants do that. There are even some deciduous pine trees. Right, if you've ever seen a larch, okay, something like that, they get their needles all go orange and yellow in the fall. They're very pretty, actually. Okay, so we see a lot of that throughout Europe, or at least it was in Europe. Okay, before the Industrial Revolution destroyed a lot of it. Okay, and kind of the eastern seaboard of the United States. Okay, and maybe some central parts of Canada. So south central parts of Canada, right, would be considered in that biome. So that's where maple and oak and stuff like that would grow. Okay, after that we've got the taiga. The taiga is the coniferous forest, or sometimes called the boreal forest. All right, and the bulk, okay, of North America is that. Okay, or at least of Canada. Okay, we got boreal forest all along through here. Okay, you're in Fort McMurray, Grand Prairie, that kind of area, that you're into the boreal forest. All right, most of Russia, okay, is boreal forest as well. Very resource-rich area, but very difficult to access. Right, we know that obviously up in Fort McMurray, it's very cold. There's permafrost, okay, and things like that. It's very difficult to work in those conditions, but we're developing technologies that help us to harness not only the lumber, but also the oil sands that have a tendency to be located underneath, okay, this type of biome. And then the last one is the tundra. Okay, the tundra means treeless. It is so cold that it is above the tree line here. Okay, that means that the soil is either poorly developed or doesn't thaw enough to support large plants that have deep root systems. So typically it is an Arctic grassland. Right? And we see that, okay, in Alaska and in Nunavut and the Northwest Territories and the Yukon, parts of the Yukon here, and Siberia. Right? That's where in old communist Russia you went if you were not favored. Okay? They would send you to the salt mines and you would just disappear. Right? That was Siberia. Very, very cold, very, very nasty, okay, place to have to live and work. All right, questions on the locations? All right, details. So, tropical rainforest. Dense would be the word to describe this. All right. If you've ever walked in a Canadian forest, it is nothing like that. All right. In a Canadian forest, you can actually look and see between the trunks of trees. There's room to walk generally. There's not a lot of undergrowth. In the rainforest, if you are not carrying a machete, you will be very quickly swallowed up by the tropical rainforest. Okay, it is very dense growth at all levels. That's the other thing that's different about it. There's actually different levels of this forest. Okay, there's the top canopy, which you can see here. This is only the top of the tallest trees. There can be up to 4 other layers below that. Okay, so there's the canopy, the subcanopy. Okay, you go even further down. Eventually, you get into undergrowth and things like that. But it's just thick. Okay, really, really thick. And if you walk into it, it is really easy to get turned around and lost because you have no frame of reference. And in fact, in certain parts of the rainforest, it is actually dark at ground level. All right, so much foliage is above you that it can block out the majority of the light. It would be like dusk, okay, when you're walking along on the ground, okay, in a thick, healthy tropical rainforest. All right. The other problem with the tropical rainforest is it's very difficult to walk in there because it's often flooded. Okay, it gets so much rain that most of those trees are growing right out of floodwaters. Okay, they have special adaptations that allow them to live when their roots are submerged, okay, for long periods of time. All right, so general characteristics of the tropical rainforest. Okay, about 13% of the Earth's land surface. That number could be significantly smaller now due to deforestation. Okay, these complex and variable forests grow in areas that have no distinct seasonality. Right, there's no winter, there's no summer. Okay, the temperature remains very constant. Okay, all year long. Right, and we can see that rainfall is also quite high. So if you're looking at the temperature levels here, pretty much every day is around 28 degrees. And if you look at rainfall, there's not a lot of fluctuation. This would be what they would call their dry season, when they only get 150 millimeters of rain in a month. Okay, to give you some idea, we got slightly over 200 millimeters last year in June. And look what happened. Okay, yeah. They get that much every month, all year long. Okay, very, very different, okay, set of climate and conditions there. That's why flooding is so prevalent. All right, you look in these pictures here. These were taken in Hawaii. All right, when we look at mountains here, what do we see? Rock, yeah. Okay, you see rock, you see some snow, right? You rarely see growth all the way up every single surface, no matter how steep. Okay, there's something growing in the tropical rainforest because it's just that wet. Okay? Plants can always have access to water and nutrients and things like that because it rains so much. Every single mountain looks like a chia pet. Okay? If you've ever seen what a chia pet looks like, right? It just grows all over the surface of it because you're always watering it. Okay? And it can literally grab, you know, the moisture from any surface, right? In our mountains, that's not the case. Okay? They're cold, they're dry, and so the tops are often just bare rock. All right, precipitation exceeds evaporation. That means flooding. Okay, there's more water coming down than can actually evaporate off the ground. All right, so it piles up, it puddles up, it floods. Okay, you get thick, luxuriant vegetation. Okay, high temperature, high rainfall, high humidity. If you don't like it muggy, do not go to the tropical rainforest. All right, it will be unpleasant for you. If you don't like bugs, don't go to the tropical rainforest. You will not have fun. All right? The majority of the animals that live in the tropical rainforest are bugs. All right? Because it's very difficult for large mammals to survive in an area that it's difficult to walk around in. Right? It's difficult to hunt, it's difficult to move, you don't have any place to make shelter or whatever. So you typically see a lot more bugs and snakes and things like that that maybe you don't like, okay, on your holiday. All right, soils in the tropical rainforest are poor, believe it or not. Seems odd, it's kind of counterintuitive that a place that has so many plants could have rotten soil, but it's true. Okay? The presence of frequent flooding washes away the topsoil. Washes away and leaches out the nutrients. Okay? Leaching, okay, is a process that happens this way. When water sits on top of the soil, okay, it begins to dissolve the solutes and minerals and nutrients that are in the soil. It begins to dissolve because the soil is saturated. Okay? That solution then washes away with the floodwaters, leaving behind soil that has been sucked dry, okay, of all of its nutrients. All right, so people in the rainforest, they have a difficult time producing food by agriculture by the same method we do, because they cut down the rainforest and they plant crops in soil that basically has no nutrients in it. So without the input of large amounts of fertilizer, soil eventually just craps out. and it can't produce anything, and nothing can grow in it. All right, and so it's very, very difficult. And what they end up doing is just moving on and cutting down another section of rainforest, using it for a couple of years before the soil craps out, and then they move on again. All right, so it's not that they don't know any better. It's just that that's all there is. Okay, and that's all they can do. And you can see here these pictures of this soil. It looks, poor. It's got this kind of pale reddish color, which usually indicates that a lot of the organic material has either been washed away or the nutrients have been sucked out through that process of leaching. Okay. All right, so big thing there would be this. Okay, intense rainfall causes the removal of nearly all nutrients. So where do the trees get their nutrients from? Yeah, from the water. They can actually draw, okay, when they're submerged and flooded, they can actually draw nutrients straight out of the floodwater, which is rich in nutrients, okay, because it's flowed over all this area and sucked all the nutrients out of the soil. So it's actually very nutrient rich, and that's how most of those luxuriant plants grow, is they take it right out of the floodwater. Their roots are almost entirely for anchorage as opposed for nutrient absorption. All right, soils in the rainforest look like this. Okay, we talked about the A, B, and C horizons. The A horizon is thin to absent. Then there's a thick B horizon made of clay. Clay sticks around. Right? Clay doesn't wash away easily because it cements together. All right, and holds there, so it doesn't dissolve and it doesn't wash away. It creates thick, sticky mud, right, that kind of stays put. And then way down underneath that will be highly weathered rock, parent material. Okay, depends on the place. Right, can be anywhere from 1.5 meters to 6 meters. Okay. All right, the plants. Okay, give you some idea here. This is a picture taken at ground level in the rainforest. Right, this is not what ground level in a Canadian forest looks like. You can't see anywhere. Right, in fact, my dad and I went in here. We thought, well, let's go for a little hike in the jungle, and it was like an hour and a half later before we were able to find our way back out, because the jungle just closes in behind you. All right, and it's very easy to get turned around. You can't see the sun. Okay, you can't hear anything because there's so many plants and trees in the way that they block the sound. Okay, and it is really, really easy to get turned around. All right, we were fortunate in that there had been actually some logging that had happened not far from where we entered the jungle, and we were able to get into a clearing and get our bearings. All right, had that not been there, we might have just disappeared. Okay, because we were stupid and went in there without a machete. Okay, you always want to carry a machete when you go in the jungle, because then you can clear the brush away and leave a trail to follow. Okay. Here's what some of the tropical rainforest plants do as an adaptation. I think I showed you a picture like this previous to this, right? Yeah, it was in the hydrophyte slide. They have these roots here that are mostly for anchorage, okay, that are in the soil, and then they've got these ones here that are the snorkel roots, okay, and the snorkel roots get oxygen and nutrients to support them when the other roots are submerged. Okay. Now, big things in terms of variety, okay, variation, diversity. The tropical rainforest is exceptionally diverse. In a Canadian forest, like if you go into, let's say, Banff, you're looking at maybe 4 or 5 different kinds of trees. You're going to have Engelmann spruce, Douglas fir, lodgepole pine, black spruce, okay, maybe 4 or 5 different tree types. In the tropical rainforest, there can be up to 100 different species of tree in a 1 hectare area. To give you an idea, 1 hectare is approximately the area enclosed by our running track. Okay? In Canada, you'd be lucky if you had 100 trees, period, in that space. Okay? In a tropical rainforest, you could have 100 different kinds of trees and several thousand of each type in that kind of area. That's how dense the tropical rainforest can be. All right? Dylan, wake up. All right. Animals. All right? Notice here that there's no really big animals. The idea that the lion is the king of the jungle is a fallacy. Okay? Lions don't live in the jungle. They live in the savanna. Okay? In the tropical rainforest, there just aren't big predator animals. There also aren't big herbivores because there's no places for them to graze. There's often flooding, which makes it difficult for them to survive. And one thing you won't see are subterranean animals. If you are subterranean, where do you live? Underground. Living underground is not advisable in an area that is frequently flooded unless you have scuba gear. Right? It's not advisable. So, most of the animals are arboreal. They live in the trees. They'll spend their whole lives in the trees, swinging from branch to branch. Okay, so you got little things like red pandas, this cute little guy here. Okay, and lots of bugs. All right, so you got like dung beetles, walking sticks, praying mantis. Okay, you got lots of amphibians, frogs and salamanders and newts and things like that. Okay, your biggest mammal would probably be the three-toed sloth. Okay, the three-toed sloth is the slowest mammal on Earth. All right, when it is at a dead sprint, it moves at about 10 centimeters per second. Okay, because it doesn't have to. It doesn't have any predators. It just hangs out in the trees. It's got claws on it, you can kind of see in this picture, that are almost like the top of a coat hanger. Right? And it just slips them over top of the tree branch and hangs out literally. Okay? Just hangs there. When it wants to move somewhere, it kind of shimmies along the tree, okay, using these things, and then picks the leaves and eats them. They're very mellow. Right? Because they don't have to be excitable, they don't have to move quickly. Again, they don't have any predators to evade for the most part. Okay? At least not that can climb a tree like that and just hang out there. But if you've ever seen their face, they got a very weird look. Their eyes are very close together and they have a strange mouth. Yeah. Possibly, but it'd have to be a big snake, like a giant anaconda or something like that. Yeah. Again, typically, they have difficulty moving onto smaller branches because they're too heavy. So. All right. So there's lots of different habitats and niches or niches, however you pronounce that. Okay, in the tropical rainforest, lots of jobs and places to live. Okay, in the tropical rainforest, if you're an animal, and that is why there are so many of them. Okay. All right. Other problem with being in the rainforest: lots of animals and plants are endemic, which means they only live in a very small area, and that's the only place on Earth that organism exists. All right? And so deforestation is a real problem because it can cause the extinction of organisms we didn't even know were there. All right? So also a problem in the tropical rainforest. Okay, chemical cycling, or the cycling of nutrients. Stuff breaks down really, really fast in the tropical rainforest because it's hot and it's wet. Okay, those conditions lead to the growth of fungus, decomposing insects and other organisms, as well as bacteria. Right? All of those things help to decompose material and dead plants and animals very, very fast. Okay, a tree falls in the tropical rainforest, it makes a sound, and then it decays in like a matter of weeks. All right, because it will be covered in stuff in no time at all, covered in mosses and fungus and all kinds of bacteria and whatever, and there'll be big ants and other kinds of organisms that are chewing on it, okay, for food. It'll break down very, very quickly. In fact, sometimes you'll see plants growing out of fallen trees on the ground. It happens that quickly. Dom. Well, there's lots of bugs. But I mean, there'd be mosquitoes, certainly. There'll be lots of, there'll be biting insects. There are animals for them to feed off of, but a lot of the insects feed on other insects. So if you look at a food chain in the tropical rainforest, it's very, very long because you got a bug that eats plants, and a bug that eats that bug, and a bug that eats that bug, and that happens like 4, 5, 7, 8, 9, 10 times in a food chain, and then there might be a bird at the end of it that eats that bug. Right? So the food chains are very different just because there are so many different kinds of insects. All right, so food chains, like we said here just a minute ago, are long and extremely complex. Okay, and obviously this, there's very dense, vegetation and lots of decomposer organisms that help to cycle nutrients very quickly. All right, the savanna. All right, so the open expanses of Africa, okay, are the savanna. But it's not all grassland looking. Okay, there's often woodland as well. Right? Different type of woodland, obviously not tropical rainforest woodland, but woodland. Okay, so there'd be lots of trees and things like that in groups and bunches. Okay, now believe it or not, the savanna gets as much or even more rain than the tropical rainforest does. But instead of growing a tropical rainforest, this develops. The reason for that is this: it's not evenly distributed throughout the year. Right? In the tropical rainforest, the rain is pretty much even. In the savanna, you have the monsoon season for 3 or 4 months, and then the rest of the year, not a drop of rain. Okay, so there's a very long, dry, hot, dry season. Right? And the plants have to be able to survive on the water that was delivered during the monsoon season. They got to survive to the next monsoon, right? And that's a very, very long time. So you don't get large, luxuriant vegetation growing in a situation like that. Okay, you get more prairie-like stuff. Now this is a tropical grassland biome for the most part, right? And in a tropical grassland biome, you get very different animals. Right? You get large herbivores and you get large carnivores as well. Right? If all of your organisms are small bugs, all your carnivores are going to be small bugs. Okay? But if you've got big, wildebeests and elephants and things like that and giraffes, well, your predators have to be bigger. Right? And that's why in the savanna you've got lions, cheetahs, okay, things like that, hyenas and stuff that are larger organisms that typically hunt in packs, okay, that can take down big game. All right, so climate, you can see here, the monsoon season is very clear. Right? The monsoon season is here, where we've got the big precipitation bars, but you notice the similar temperature pattern, okay, to the tropical rainforest, because it's near the equator. Anything near the equator has that temperature pattern, because it gets the same amount of sun all year long. Okay, now here you can see some of the animals, okay, and some of the more wooded area of the savanna. But what's this big thing that the tiger is sitting on there, or the cheetah is sitting on? It's a termite mound. Okay, because of the amount of grass and trees and things like that that are in the savanna, and because a lot of them have to go dormant for long periods of time, there's an exceptionally large amount of food available for termites. Okay, termites eat only plant material. Right? You never have to worry about getting bit by a termite. But they can turn a 2x4 into sawdust in a matter of hours if you have a colony that size. And that mound there is made out of termite poop, which is basically sawdust. Okay? Because what do they eat? Plant material, trees, things like that. All right? We don't worry about termites here because they can't survive the cold winters that we have. But in more tropical areas, they really have to be mindful of how they build their homes. If a termite gets into a house, the house can be condemned very quickly, right? Because they will eat away at the frame of the house to the point where it won't support its roof and it'll collapse. Right? So termites are a big deal in more tropical areas. Plagioclimax means an artificial endpoint is kind of reached, okay? And that's because wildfires are very prevalent, in the savanna. And so rather than getting to a further stage in kind of the evolution of this area, it tends to get stopped by wildfires. When you got 8 months with no rain, you're going to get fires happening because it gets so hot and dry. Okay? All right, lots of plants have to estivate. Okay? Estivate means they go dormant. They go dormant just like our plants do, except they do it for a different reason. Our plants go dormant because it's going to get cold. Their plants go dormant because it's going to get hot and dry. All right? Now you'll also notice that a lot of the trees here spread out horizontally. They don't necessarily get very tall. I mean, there's this one here that's kind of tall, but the rest kind of spread out horizontally. Reason for that, it helps to shade their roots. Okay? Getting an umbrella shape, okay, for a tree helps to shade a large area beneath you where your roots are and protect it from the sun and thus help it to retain moisture. Right? So that's kind of a reason for the shape of the trees you see. The other reason is if you're tall and flat on the bottom, you don't have a lot of branches for giraffes and other herbivores to chew on. Okay? So it's kind of a protective feature as well. Okay, so vegetation, like we said, many of the trees in the savanna are actually fire resistant. The eucalyptus tree can be burned right to a cinder and it'll grow right back. Okay? It's got this bark that kind of insulates the interior of the tree from the heat of the fire, prevents the sap from boiling, okay? And the plant will grow back, even though it may have lost all of its foliage. Okay? It'll grow back after a fire. Okay? Trees have to produce huge numbers of seeds each year because most of the ones that fall on the ground get eaten by termites. Okay? Termites eat any plant material. If you want to reproduce as a plant, you'd better make lots and lots and lots of seeds because most of them are going to get used for food. All right? So you see huge amounts of pollen and stuff like that on the wind, okay, in the savanna, right? Because it's the only way that plants can survive. You also have much different types of grasses than you have here in Canada. The grass is way taller and thicker. All right. In fact, there's things called elephant grass. Okay, elephant grass, and actually, I had Francois Van Tonder was in my class first semester. He's from South Africa, and he was actually telling me they had this elephant grass on their farm, and they could drive their truck, and it wasn't taller than the grass. Okay. The reason it's called elephant grass is because elephants can walk through it, and you can't see them. Okay, it's that tall. Imagine grass that could grow to be 3.5 meters tall. All right, that'd be grass that essentially goes taller than this roof. All right, it's more bamboo-like. It's much thicker. Okay, but it's still a grass, and it gets very, very tall because there's lots of rain for a short period. It grows heavily during that time, and then being tall like that shades the roots. If you're tall and thick, they shade the roots from the sun, and you can continue to grow even during a long dry season. Okay. All right, soil, okay, what you see here in feet, okay, this is still all topsoil. All right, they can have topsoil that's a meter thick, because what does grass do every year? It dies, and new grass grows up underneath it. Okay, and so there's always this thick mat of organic material that builds up under grasslands. That's why the soil here is quite thick. Right, not as thick as this, obviously. Okay, but every year grass dies, new grass grows, and the grass that died the year before builds up this thick mat of organic material that eventually turns into topsoil. Okay, so you see lots and lots of it. Okay, in the savanna. Okay, it does tend to be a little sandier, okay, but it's still very, very thick. Okay, animal diversity is low. Not like in the tropical rainforest where you had all these bugs, okay, and these really, really long food chains and whatever else. In the savanna, food chains are really, really short. There's the animal that eats the plants, and then the top carnivore that eats that animal. Okay? Lions prey directly on the herbivores. That's a short food chain. All right? Longer food chains would be, you got your herbivore, and something eats the herbivore, and something eats that, okay, and so on and so on. In the savanna, the food chains end after about 3 steps. Producer, primary consumer, secondary consumer, done. All right? Very, very short. All right? Even with all of those termites, even those food chains end fairly quickly because what eats termites generally? Birds. Yeah, okay. And birds are typically near the top of their food chain because they're able to fly. They can escape most predators, and as a result, they're near the top of their own food chains. All right. There's also lots of scavenger organisms. Okay, termites would be a scavenger organism. Okay, in the savanna. But you've also got your hyenas. Okay, your kind of wild dogs. Right, and they pick over the kills of the lions after the lions are done with them. You got buzzards. Okay, buzzards will pick over a carcass after the lions have eaten the stuff that they like. Okay, they'll come and chew what's ever left off the bones. All right, so there's a lot of nutrient cycling that goes on there. Okay, chemical cycling is rapid. Again, there's moisture and there's heat, and those things breed all kinds of decomposing organisms, fungus, bacteria, insects, okay, and things like that. Here again, you can see that umbrella shape, okay, that a lot of the trees have, especially the larger trees, okay, and that again helps to protect their root system. You can see that there's a lot of shade underneath where all the zebras and antelope are hanging out, okay, because it's nice and cool underneath there. During the monsoon season, you'll often see this condition, though. During the monsoons, flooding happens. Okay? If you're going to pound down 1,000 millimeters of rain in 2 months, it's going to flood. Okay? And that's what happens. Right? But that stuff often runs off, and when it runs off, it does cause a lot of erosion. If you recall last year during the flood, okay, the rivers were very, very brown because they're carrying so much material. That's erosion. They're carrying away topsoil and other types of sediment. Okay? So there is a lot of erosion due to rainfall in the savanna. Yeah. All right, deserts. Okay. This is not a hot desert, okay? Well, at least not all the time, okay? In Arizona, yes, in the summertime, the desert's very hot. But in the wintertime, it can get near freezing, or in places like Flagstaff, Arizona, it can get below freezing. All right? In fact, there's a big ski hill around Flagstaff, Arizona, if you can believe that. All right? Deserts don't have to be baking hot. They don't have to be like what you would see in like Tunisia and Egypt and those kind of places where it's in the Sahara. If you don't know where Tunisia is, if you've seen any Star Wars movie that had Tatooine in it, that's where they filmed Tatooine. It's in Tunisia, where it's just nothing but rolling dunes of sand. It is the hottest, driest place on Earth. All right, but deserts don't have to be hot. They just have to be dry. All right, different kinds of organisms can survive there. There are plants, obviously, that can survive in the desert, but they have to be adapted to extreme periods of drought. Now, does that mean you want deep roots or shallow roots? It depends. You can have both. All right. Some of the plants will have really, really deep roots that actually tap groundwater. So they'll go into a well or an aquifer, okay, and they'll draw water right out of there. Other plants will have them right near the surface and very, very widespread. And as a result, anytime it does rain, they can absorb lots and lots of water because they have a huge surface area from which to draw. The saguaro cactus can have a root radius of up to 30 meters. Okay, so its roots are only this far underneath the surface, but they can spread out up to 30 meters from the plant. All right, that's a long way. That's a lot of surface area to draw water from when it does finally rain. All right. Okay, so a hot desert. Okay, hot desert is going to have still less of a bell curve shape. All right, so an equatorial desert isn't going to have much difference between summer and winter. Okay, and you can see here, somewhere between 24 and 35 degrees Celsius. Okay, for most months, and you can see again rainfall. The wettest month, okay, got 60 millimeters of rain. All right, 60 millimeters of rain is 6 centimeters. About that much. That's the wettest month. How many months are there where there's no rain? A lot. Okay, so very, very dry. That's the key. Okay, doesn't mean they're not green. All right, if you're down in Arizona in like April and May, it's actually quite green. It's quite pretty, actually. Lots of the cacti are in bloom, okay, and lots of the other plants have got their leaves out because it's just been winter, it's just been spring, they've just gotten whatever rain they're going to get for the year, and they're very quickly going through their reproductive cycle in order to make their seeds and then go dormant. All right, so, but it can get quite green, okay, during those times. You got a question, Seth? Yeah. All right, and again, you often see deserts in the rain shadow of mountains or along coastal areas where the wind is blowing the wrong direction to bring moisture in from the ocean. It's actually blowing out onto the ocean. Okay, that's actually where the Sahara is. The winds tend to go the other direction that way. All right, again, these are kind of more northerly deserts. Okay, this is, in Arizona here, and you see plants are sparse. They're not dense, but they're there. Okay, and you got your cactus. Okay, how old does one of those have to be before it grows its first arm? And it's actually between 80 and 100 years old before it grows its first arm. So if you see a cactus that's got lots and lots of arms, chances are it is very, very old. Okay, those cacti can live to be several hundred years old. Right, so they're a very long-lived plant. All right, yeah. Okay, soil, well, that's pretty bad. If you don't have a lot of plants growing, you don't build up a lot of organic material, so you don't build up a lot of topsoil. Soils tend to be sandy or rocky or absent. All right, so you can see here the A horizon is thin to absent. Then you got the B horizon that's going to be oftentimes very saline, okay, and then you've got your parent material that is very highly weathered. All right, you don't see big chunks of rock, okay, down below. Yes. Yeah, it's typically going to be very clear and very hot. Yeah. Okay, the animals that live there, well, they typically tend to be small because being very big in the desert is tough. It means that you absorb a lot of heat and you got a lot of moisture to carry around, right? And you don't want to have to carry around a lot of moisture. So you see insects, okay, flies and scorpions and spiders and things like that, okay, that are able to have, you know, the hard carapace over themselves. They don't sweat, okay? They hide in the shade. They come out at night. Lots of animals are nocturnal. Lots of reptiles. Reptiles also don't sweat. They got scales that protect them from evaporation. They hide in the shade and come out at night often, okay? And you got your rodents that, again, don't need a lot of water, all right? And then you got, you know, predators that are good for preying on rodents. So you got hawks and foxes, coyotes, okay, things like that. But you just don't see a lot of large mammals. The exception, the camel. Okay, the camel would be the exception to that. All right. Now, if you don't sweat, how do you keep yourself cool? We talked about this the other day. If they have what? Yeah, I mean birds might eat them if they're careful. Yeah. But they would have something would eat them. Right, okay. One of the strategies can be that your fur is insulative against heat as opposed to trapping heat. You pant, which uses less water. Okay, you can see in here in the ear of this rabbit, you see all the blood vessels here. Okay, if you get lots of capillaries, okay, that's the really small blood vessels near the surface of your skin, okay, you can radiate away a lot of heat by just pumping the blood into those surface capillaries and allowing the second law of thermodynamics to take place, right? This happens to you when you blush. Right? When you blush, the capillaries that are right near the surface of your skin fill with blood. And that's why your cheeks turn red. Right? But the same thing happens if you're working really hard. You tend to get flushed. Okay? And the reason for that is you're going to start sweating, and you want that hot blood that you want to cool right near the surface where it can transfer its energy to the sweat and get cooler. Right? So that's why you typically get flushed, okay, when you are working hard. But for an animal like this, if they can pump blood into those capillaries and then just move their ears, okay, they can help to cool it off, and that's exactly what they do. What happens when you look at a computer screen? Oh, probably just because of lack of blood flow. When you're sitting for a long period of time, blood can tend to pool in places. Okay? That's how you get varicose veins too when you get older. Okay? Blood gets trapped in the lower veins of the leg and you get varicose veins. All right, chemical cycling. Is that going to happen very fast? Are nutrients going to get broken down and things decompose quickly in the desert? Yeah, it's hot, but it's not. What? What's the other thing to make things decompose that you need? Hot and wet, and it's not. It's too dry. So you don't have a lot of fungus. You don't have a lot of bacteria. Okay, you got insects, and that's pretty much what you're relying on for decomposition. Okay, carry-on animals like buzzards and things like that, and small insects that can pick over a carcass. But there's very slow decomposition due to bacteria and fungus action. Okay. All right, temperate grasslands. Now, you look at that picture and what do you see? Okay, see ground, see grass. Okay, see ground, you see grass, but you see cactus. Okay, why do I have a picture of cactus in a temperate grassland biome? Okay, can cactus grow in the grass? Absolutely. Okay, around here, down by Lethbridge, Medicine Hat. Actually, that picture is taken about 80 kilometers north of Medicine Hat in a place called Empress. Okay, you get lots of cacti around there. Okay, prickly pear cacti is what grow around here. Right. The grassland can be very dry. It can be almost desert-like, but it gets just enough moisture, or it gets just long enough winters, okay, in order to not be a true desert. All right, so this is dry prairie, okay, and so it doesn't often look a whole lot different than the desert. Okay, This is a similar place. It's only about 50 kilometers south of where I took that last picture, so it's not very far north of Medicine Hat. Okay, and you can see it looks burnt. And because it is, it's late August on the prairie. Late August on the prairie, everything has already been green. It's already, seeded out and everything's done. All right, so it's ripe and it's burnt up. All right. Your climatograms, well, here's what Calgary's looks like. Calgary's prime prairie, okay, kind of a city. And you can see, obviously, okay, we have a peak in rainfall in what month? June. June is by far the wettest month on the prairies, okay? In just about every prairie place on Earth, okay, June is the wettest month. All right, forget that whole April showers bring May flowers, okay, because that doesn't work here. All right, it's like April flurries bring flood worries or something. I don't know, okay? But it doesn't. We don't get showers in April. We get snow, okay? So, yeah, you can see here that typically precipitation follows temperature. All right, so on a prairie climatogram, you're looking at your bars and your temperature dots having the same shape. When it's warmest is when it's wettest. All right, and then typically in the winter, it's drier. Now, sometimes that seems counterintuitive. People go, we get a lot of snow in the wintertime. We do, but snow does not represent very much moisture. 10 centimeters of snow equals 1 centimeter of rain. Because remember, snow is full of air pockets. Okay, when snow falls, right, and it starts to melt in the spring, right, it shrinks first, okay, before it actually starts to disappear. Okay, as the snowflakes lose their shape, they get rounded, and that's when it kind of settles, and then it melts after that. Okay, so snow does not represent nearly as much moisture as we tend to think it does. So that's why June, July, and August, okay, maybe even May, tend to be our wetter months, but June by far. Okay. Again, the other thing you're going to see for the prairie that's different from the savanna is the bell curve on the temperature. Anything that's got a bell curve, remember, is probably north of 30 degrees latitude. Okay, so you're going to see that's not equatorial, not tropical. Tropical climates have flat temperature lines, okay, and non-tropical climates have bell curves. All right, the lower that bell curve, the colder it is. All right, you can see for Calgary, that bell curve isn't terribly low, but it's not terribly high either. Okay, we got average temperatures here of around 16 or 18 degrees, even in the warmest month. Okay, two types of prairie: short grass prairie, long grass prairie. This is short grass prairie, like you see down in southern Alberta. This is long grass prairie, like you'd see in more central or northern Alberta, like let's say St. Paul. Edmonton, okay, that kind of area, that kind of latitude, you typically get longer grasses because you get more precipitation, all right, and longer winters. Here, winters are a bit shorter and it's a lot drier, so you get different species of grass growing, so they look different. Okay, soils, thick A horizon, small B horizons, parent material underneath that, but the parent material is very deep. Right, because every year, again, organic material builds up as the grass dies, okay, and new grass replaces it. You're always getting a thick mat of humus, okay, underneath that. Okay, fauna. This is supposed to be the slide about animals. See any animals in the picture? It's because the natural animals from the prairie aren't here anymore. Okay, the animals that naturally lived on the prairie are what we call extirpated, which means they are forced off of or out of their natural habitat. Okay, you went back 200, 250 years on the prairie. What animal is there that isn't there now? Buffalo. Okay, buffalo in herds of thousands to tens of thousands. Okay, these things would clear the prairie like a line of lawnmowers strung together. Okay, they would pick it right down to the ground. Okay, in neat, like literally brush cut. Okay, the prairie as they walk along. Right. What did them in? The introduction of the horse, the rifle, and the fence. Okay, buffalo could run through a fence. Make no mistake, they're big and strong, but they don't like to. And so when they run into a fence, they go, ugh, and they turn around and they just kind of walk the other way. But it interrupts their migratory pattern, right? And so in the end result is they stop migrating, they eat up all the plants in an area and starve. Okay? Or you bring in the rifle and people hunt them for sport and force them nearly to extinction. Okay? Because they're not that smart. They're big, but they're not that smart. right? And when they run, have you ever noticed where a buffalo's eyes are? Yeah, they're on the sides, like most herbivores. Their eyes are on the side, so they have a very different field of vision. You can walk up in front of them, and they won't see you. Okay, as long as you walk, straight in front of them. They turn their head to look either way for predators, because that's better if you're a herbivore and your face is down all the time. Okay, your face is down eating grass. You don't want your eyes facing forward, because all you're going to see is the ground. When they're out on the side, you can see your predators coming. But there's a problem with that. When you get running at high speed, you don't see the cliff coming. Right? That's why the natives of Alberta would run them off buffalo jumps. Okay? If you get their head down, all they see is the side, and you make a big ruckus to the side so that they're always focused on the sides, and then you run them right off a cliff. Okay? And that's what they did. That's how they hunted them. They would run them off a cliff and then climb down and clean them up. All right? It was how you hunted buffalo if you didn't have a rifle. Okay? Worked really good. All right? If you've ever been to head smashed in buffalo jump, okay, you kind of know how that all works. All right? Bears as well. Grizzly bears and black bears used to be very prevalent on the prairies, but they're gone. Wolves as well. Okay? Because, well, if you're farming cattle or chickens or anything, you don't want them around, right? Because they're eating your animals. So they were shot and killed and eventually just disappeared. Right? Now we only see them in the mountain parks. They are no longer in their natural range. It used to be a lot bigger. Okay, the animals that have replaced them. The prairie dog, okay, so you got gophers of all kinds, okay, ground squirrels, all of those kind of things, because there's a lot less of the big game, the buffalo and whatever, that would eat the grass. Now the gophers have their free reign, okay, and the animals that feed on the gophers, coyotes, foxes, okay, those animals typically do okay because they're not usually too problematic. All right, chemical cycles are reasonably quick, but remember, there's a big freeze-off for several months, and that big freeze-off does tend to curtail the actions of fungus and bacteria, okay, as well as insects. So things take longer to decay in the prairie than they would in a more tropical place because they can only work on them for half the year. All right. Okay, the temperate, deciduous, broadleaf, evergreen, sclerophyllous forest biome. This basically includes deciduous biome as well as the Mediterranean biome. We're kind of combining them together here. Big thing, all your plants lose their leaves at some point during the year. Okay, climatogram. What do you notice is really the defining characteristic of this area? What do you notice about the rainfall? It's pretty high, but it's also pretty steady. It's even. Right? There isn't a peak at any point in the year. It's pretty much uniform across. That's the defining characteristic of the deciduous biome's climate, is that it is even rainfall across the board. Okay? That's how you get deciduous plants. They need a steady supply of water. They can't go months at a time with dryness. It just won't work. You also have milder winters. Okay, not the harsh, really dreadful cold ones that we tend to get on the prairies. Okay, they tend to be a lot shorter and a lot milder. Okay, and that's why you get quite a different climatogram than ours. Okay, but again, the big thing to look for here is rather uniform precipitation. Okay, vegetation, again, you got oak, beech, hickory, okay, birch, hazel, sycamore, maple. Maple's a big one, obviously, up here. Okay, in the Mediterranean, you'll get more drought-tolerant stuff like olive, sessile, oak, and pine. Okay, but again, this is more of a Mediterranean-looking kind of forest, okay, as opposed to ours, which we know what they look like. Okay, soils. Again, you got a reasonable A horizon because every year you get a buildup of leaves. Right? Every year they're dropping leaves. Those leaves break down and become new soil. Okay, but you do tend to have a fairly good B horizon. The C horizon tends to be quite deep and highly weathered. Okay, food chains. A little bit longer, right? Because you tend to have more small organisms and rodents and things like that. So you'll have wolves and you'll have foxes and weasels and owls and carnivorous birds. Okay, lots of bugs again. And then you do have some large herbivores as well. If you got large herbivores, then you need large carnivores. Black bears are also not outside the realm of possibility in that biome. Not so much in the mountains. We don't typically have a lot of deciduous trees in the mountains. Ours are more coniferous. Okay, so this is more Ontario, Quebec, eastern Manitoba, and the Maritimes would be more like this. No, Colorado's much more like us. Mountain climates tend to be boreal as opposed to deciduous. Okay. Okay, chemical cycling, again, a little bit quicker. It's more moist. It's a little bit warmer. Okay, and you've got cover for the insects in all of that leaf litter. Okay, so there's lots of opportunity for decomposition to go. But again, there is a freeze-off every year. It's just not as long and harsh. Okay, decomposing organisms can work on stuff for maybe 8 months of the year. Okay, so it's a little longer than it is out here. All right. All right, we'll go as far as we can here. The boreal forest. Okay, you see a lot of that when you go to Banff, you go to Kananaskis, go to Jasper, you're in the boreal forest. Okay, you go to Fort McMurray, Grand Prairie, you're in the boreal forest. Oddly enough, since it's called Grand Prairie, but okay, you're into the boreal forest when you get up there. Okay, what you see in the boreal forest is like a carpet of spruce. Okay, a carpet of coniferous trees. Coniferous trees are ones that have needles for their leaves and cones for their reproductive structures. All right, that's what a pine cone is, guys. There's male and female cones on any kind of spruce or pine tree. All right, one makes pollen, one makes seeds. Okay, so that's what we've got there. Big thing, winter lasts a long time, and as a result, these are actually a lot drier than you might think. All right, we'll pick it up tomorrow from there.